Hello and welcome to K2P classes. Today class topic is heights and distance. Actually, height and distance is application of trigonometry. So we will in this class try to solve some practical problems of heights and distances. The moral teaching is increase height of your kindness and decrease distance from God. Class objective: simple and believable problems on heights and distances, bearing of point, angle of elevations, depression. Here we are quickly recapping trigonometrical formula, trigonometrical ratios. Consider ABC as a right angle triangle whose angle A is right angle, angle B is theta. If we consider this angle, then the AC is called opposite side and AB is adjacent, or this is also called base and this is also called height. So sine theta is opposite by hypotenuse, AC by BC. Cos theta is adjacent by hypotenuse. Tan theta opposite by adjacent. Sec theta into cosec theta is 1. Cos theta into sec theta is 1. Tan theta into cot theta is 1. Tan theta equal to sin theta by cos theta. Cot theta is cos theta by sin theta. Sin theta whole square is written as sin square theta. It doesn't mean sin square into theta. Okay, it is sin square theta. Two basic formula of trigonometry: sin square theta plus cos square theta equal to 1. Sec square theta minus tan square theta equal to 1. Early beginnings uses of trigonometry for determining heights and distance. The Great Pyramid at Giza near Cairo, one of the 7 wonders of the ancient world. This is the one of the earliest use of trigonometry. People used trigonometry for determining height of the pyramid. Look, this is the pyramid here, and it is difficult to find out height of pyramid. The distance from any point to any point on the surface can be determined easily, but there is a challenge to find out height. So what technique we have used? The human being at that time used proportional ratio. If two triangles are similar, then their corresponding sides ratio are same. So if a person is standing here and this is the person's shadow, so we can find out the shadow, right? The length of the shadow, and we can also find out the length of the person because it is a small height, and then this angle can be found out. Remember, again, this is also the shadow but the bigger object. So the distance, the ratio of height and base will be same. So these are similar triangles. Look, so it is 6 feet, person is there, 9 feet height. So here we know the 720 feet is the shadow length. Suppose the height is h. So h by 720 equal to 6 by 9, because the two triangles are similar, and similar triangles have one property, that its corresponding sides ratios are same. So from this formula we can say h equal to 480 feet. Discuss how the following sequence of diagrams allow us to determine the height of the Eiffel Tower without actually having to climb it. Look, a person is sitting here and this angle is 45 degrees. And he had to find out height of the tower. So what he is going to do next? Simple. He is going to measure the distance between the person and Eiffel Tower. And he can measure it through tape. So it is 324 meters. And the angle is 45. And if the angle is the 45, we know that tan 45 is 1. That means at that time when the angle is 45, the height and the base are same. So if this is 324 meters, surely the height of the Eiffel Tower will be 324 meters. In this way, the height of the Eiffel Tower is determined. Some Eiffel Tower facts. So now we are in the history class. It is interesting to know few facts about Eiffel Tower. Okay, let us return to the math class. We will learn here what is called angle of elevation and angle of depressions. An angle of elevations is the angle measured upward from a horizontal to a fixed point. That is angle of elevation. The angle of depression is the angle measured downward. The keyword is downward from a horizontal to a fixed point. Let us see in the diagram. So this is angle of elevation. Well, it is measured upward. So we are measuring upward. Here this is angle of depressions, because here the angle is measured downward. Here the look arrow is upward. Here the arrow is downward. So this is 25 degrees. So look, angle of elevation and angle of depressions are same because these two are the parallel lines. And if a third line crosses parallel lines, these two angles have to be same. Now let us solve some problems. Remember, while solving the problem, fundamentally you have to draw the situation of the problem. Whatever statement is written, just draw the outline, diagram, and then see which trigonometrical ratio can be applied. And then apply that trigonometrical ratio and you will find the answer. Look here. At a point on the ground, 50 feet from the foot of the flagpole, the angle of elevation to the top of the pole is 53 degrees. Find the height of the flagpole. First of all, we have to draw a drawing. So look, this is the flagpole. This is the distance. What is written? Point on the ground 50 feet from the foot. 50 feet from the foot of the flagpole. The angle of elevation upward is 53 degrees. Then find the height of the flag. You have to find this h. Now it is very simple. H and base is given and there is one angle 53. So just you have to apply your brain which trigonometrical ratio should be used here. Try. Yes. What do you tell? Tan theta, right. So it is tan theta. Opposite, adjacent. Opposite by A, right? Here because opposite is given, adjacent is given. So this will be used. So tan theta is height by base. So tan 53 is h by 50. Now, what is the value of tan 53 degree? For that, you have to look table. In your examination, the 53 may be 45 degree, 30 degree, 60 degree. Then it is easy to find out because for 0, 30, 45, 60, 90, we know the value of the trigonometrical ratios. But if it is 53 degree, we have to just see here. So this is table. So 53, yeah, 53 here, and 10 is what? 1.3270. So the value of tan 53 degree is 1.3270. So h equal to tan 53 multiplied by 50, and that is nothing but 66.36 feet. Okay. Second question. A 20 feet ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What angle does the ladder makes with the ground? So let us first draw the drawing. So this is the ladder. This is the wall. 20 feet ladder. So length of the ladder is 20 feet. And its base is at the distance of 8 feet from the base of the building. So this is the 8 feet. And we have to find out the angle between the ladder and earth or base, ground. Let us, it is x. So now just think which trigonometrical ratio include base and hypotenuse. Just give little bit work to your brain. Yes, correct. It is cos. Yeah. So adjacent and hypotenuse. It is cos. So first step is draw a triangle to fit the problem. Level side from angle's view. From angle view, it is adjacent from the angle view. If this is the angle, then this will be opposite side. And identified trigonometrical function to use. So here we have identified cos. And set up, the fourth step is set up equation. Cos x degree is 8 by 20. So 8 by 20, if you see, so what is the value of 8 by 20? The 8 by 20 will be, if we use calculator, 8 by 20. So 0.4. So we have to see 0.4 for cos. Okay. So we see here 0.4 for cos. 22 degree. 0.4. No, it is for 10. We have to see for cos. Cos. Then we have to see here. 0.4067. So near, almost near. So it is again 66 degree. So it becomes 66 degree. Accurately, if you will see, it is 60 because it is 0.4. Here it is 0.467. So exactly for 0.4, if you will determine, it will come 66.42. So the answer is 66.42. Now, at the circus, a person in the audience watches the high wire routine. A 5 foot 6 inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience members from the base of the platform? If the angle of elevation from the audience members line of sight to the top of the acrobat is 27 degree. Look, 6 inch means 0.5 feet. In 1 feet there are 12 inches. So 6 inch means 0.5 foot. So the height of the person is 5.5 foot. And the height of the platform is 25 foot. So the total height will be 25 plus 5.5. So the total height is 30.5. An audience is sitting here. And when he is seeing the acrobat here, he is making one angle of elevation of 27 degree. The question is how far the audience is sitting from the base of the platform, right? So draw the triangle to the fit problem. Draw a triangle to fit problem. So we have drawn the figure. Level side from angles view. If this is 27 degree, so this is considered adjacent, this is opposite side. Identify trigonometrical function to be used. So since it is opposite and adjacent, it is trigonometry 10. Yes, it is right. So 27 degree is opposite by adjacent, that is 30.5 by x. And if we find the value of x, it is coming 59.5. How we are calculating? Look, the x into 1027 equal to 30.5. So x equal to 30.5 by 1027. And what is 1027? The 1027 value can be found out from here. 27. So this is 27 and this is 10. 0.5095. This is 10. Right? 10, 27. 0.5095. So if you divide 30.5 with the value of 1027, we will get this value, x equal to 59.9. A 25-meter tall lighthouse sits on a cliff top, 30 meters above sea level. A fishing boat is seen 100 meters from the base of the cliff, vertically below the lighthouse. Find the angle of depression from the top of the lighthouse to the boat. Let us make the drawing here. This is your lighthouse, this is the cliff, and this is the boat. The height of the cliff is 30 meters, right? And the height of the lighthouse is 25 meters. This is 25, this is 30. So the total height from the sea level up to the top of the lighthouse is 55 meters. And the distance from this place to boat is 100 meter. It is given here. 100 meter from the base of the cliff. From the base of the cliff. Now the question is, what is the angle of depression from this point? So we have to find angle of depression here. So if this is D, naturally this will be also D, because angle of depression is equal to angle of elevation. Since the angles of elevation and depressions are equal, so this is also D, this is D. So tan D is height by base, that is 55 by 100. And what is 55 by 100? 55 by 100 is 0.55. Now we have to see for 10 degree what is 0.55. So 0.55 somewhere here for tangent 0.55, yeah, this 29 degree, 0.5543. If we take only 2 digit after decimal, it is 0.543 and it is 10 degree, 10, right? So 10, 0.5543 is 29 degree. So this is angle D is 29 degree. Look, if this is looking a little bit complicated, if you see how clean this triangle is, the base is 100, height is 55, we have to find out angle D. Simple, height by base, and just if you put this, it becomes real picture. If you remove this, it is a normal triangle problem, right? Let us consider the next problem. A 22 meter tall lighthouse sits on a cliff top 35 meter above sea level. The angle of depression of a fishing boat is measured from the top of the lighthouse as 30 degree. How far is the fishing boat from the base of cliff? Again, this is the cliff, this is the lighthouse, and this is the boat. What are the given? The height of the light boat is given as 22 meter, and the height of the cliff is 35 meter. So the total height from the sea level to the top of lighthouse is 35 plus 22 that is 57. We have to find out distance between boat and just vertically below the lighthouse. Suppose this is x, and angle of depression is given as 30 degree. So angle of elevation will be also 30 degree because these two lines are parallel. Now see what are the things we know. We know this angle. For this angle, this is the height or opposite angle, and this is the adjacent angle or base. So naturally here tan theta formula will work. So tan 30 equal to 57 divided by x. And what is the formula? What is the value of tan 30? You must remember the value of tan 30, and that is here 30. 1030 is 1 by root 3. So you can just determine the result in term of root 3 also, or you can know the value from the table also. So 1030 is 0.774 or 1 by root 3. So x equal to 57 by 1030, and 1030 is 1 by root 3, so x equal to 57 into root 3 also. Or you just use the value of 1030 as 0.574 and you will get this value 99 meter. Again, see how beautiful this triangle is. There is no complication. It is a simple right angle triangle, and this angle is 30, height is 57. You have to find out base. Simple trigonometric formula. Trigonometry. This is the height and distance is use of trigonometry. If you know trigonometry, you can very well solve any problem of heights and distance. You have to just apply little brain. Look how complicated this diagrams is looking, but actual problem is very simple here. Now, another problem. A boat sails due east from a harbor to a marker buoy B 15 miles away. At B, the boat turns due south and sails for 6.4 miles to a lighthouse. It then returns to harbor. Make a sketch of the trip and calculate the bearing of the harbor from the lighthouse to the nearest degree. Oh, here is a new word, bearing. No problem. Let us first see what is called bearing. Bearing to a point is the angle measured in a clockwise direction from the north line. What is north line? So this is the origin. So north is upward, south is here. So you have, and this is the point A. So just join the point with the origin, right? And from north line, from go anti-clockwise, and whatever angle is this angle is called bearing of line A. I hope you understand. Now let us solve the problem. So first draw the sketch. So this is a harbor. From here ships goes for 15 miles up to point B. Then it go just south. South means downward. Up to 6.4 miles, and then it returns, goes to harbor. Means here. Means it goes from here to here. Now the question is, calculate the bearing of the harbor from the lighthouse. From the lighthouse. Simple. 10L. This is your angle L. So 15 by 6.4. Since this is L, so for this angle, this will be height and this will be base, or opposite side and adjacent sides. So 10L is 50 by 6.4. It is 2.33. Now we will see for what value of angle 10 theta is 2.343. 2.343. 2.343. Look, this is here 67. 2.3. Nearest one is 67, right? So you can take as it is 66.9 degree. That accurate value is 66.9. So this angle is 66.9. Now asking bearing. What is bearing? Bearing of H with respect to lighthouse. So bearing means, as I told you, angle from the north line, in this case this is the north line, up to the line, joining line of origin and the point. So if you see this one, the red angle, that is bearing of H with respect to L. So we know that if you round a circle, if you go around, complete one circle, it will be 360 degree. So the red one, this will be 360 minus 66.9. So it is 293 degree approximately, because it is asking us nearest degree. Otherwise 360 minus 66.9 is not exactly 293. It is 360 minus 66.9. It is 293.1, but nearest it is 293. Fine. So let us see the next questions. An Indian Air Force aircraft takes off from a point W on a navigation exercise. It flies 430 miles north to a point P before turning left and flying for 570 miles to a second point Q west of W. It then returned to the base. Make a sketch of the flight. So let us make a sketch of the flight. Let us read: an aircraft take off from a point W. So this is point W. On a navigation exercise, it flies 430 miles north. North means upward. So it is 430 miles up to point P. Before it turned left, so not right, it turns left. Fly for 470 miles to a second point Q west to W. If it is left, and then it will go like this. But what is written? Written is flying 570 miles to a second point Q west of W. So this is W, this is side east and this side west. So west of W, from here it takes left and moves something like that and come to a point Q which is west of W. Means on this line west of W. So why this point Q is here? Because it is written west of W in same line, and then it returns to base. So sketch is complete. The question, next question is find the bearing of Q from P. Bearing of Q from P. Okay. Cos P. This is P. So cos P will be, this is for base and this is the hypotenuse. So 430 by 530, it is 5.754. So we have to see cos 0.574. 0.574 for cos, 0.5 point, no, what was that? 0.5, no, 0.754, sorry, 0.754, 0.754 this. So this was cos 0.754, it is 41 degree. So the value of P is, angle is 41 degree. Okay. 0.754. 0.754. This is 41 degree. Now we have to find out bearing. So bearing is what? Bearing is from the north line till that line. So it is asking bearing of Q. Bearing of Q. This is the origin. So join it. And whatever angle it is making from the north line. So see, from the north line up to this red one is 180 degree. As we know that on a straight line you take any point, one side is 180 degree. And then we have to find out the bearing. Bearing is from here to here total. So 180 degree plus 41 degree, that is 221 degree. So this is the bearing of point Q from P. Again boat, lighthouse. Angle of elevation to cliff from boat is 30 degree. From this, now from here, each side, from boat it is given 30 degree. And angle of elevation from the boat to the lighthouse, it is 45 degree. So the bottom of the lighthouse or top of the cliff, the angle of elevation is 30 degree. Now angle of elevation up to top of the lighthouse is 45 degree. If the height of the cliff is 10 meter, find the height of the lighthouse. We can take root 3 equal to 1.732. Interesting question. So in the right angle PAB, tan 30 degree equal to BA, height by base. So AB by AP, 1 by root 3, AB is 10, so 10 by AP. From here we can say that AP equal to 10 root 3 or AP equal to 13.32. So now AP is known. Now we have to find out the height of the light boat. Let us height of the light boat is X. So now in the bigger triangle PAD, this is 45 degree. So tan 45 degree is equal to height by base. So AD by AP. Now tan 45 degree equal to 10 plus X, because this height is 10 plus X by AP. AP we have already derived 17.32. So 10 plus X equal to 13.3. Or if you solve this, it is X equal to 10 root 3 minus 10, that is 7.32. So the height of the lighthouse is 7.32 meter. Look, if you see this, it is very easy. From a smaller triangle, since height is given, we have calculated the base. In the bigger triangle, height was not known or half known, it is from 10. So 10 plus X, and base was known. So we have found out. So if we know AD, look, if it is 45 degree, the base and height has to be same. So if the base is 17.32, naturally the total height has to be 17.32, because if it is 45, tan 45 means what? Tan 45 value is 1 and tan 45 is height by base. So when it will come 1? When height and base are same. So the total height is 17.32 and this much height is 10. So what is the rest of the height? That means height of the lighthouse, 17.32 minus 10, that is 7.32. So look, it is so simple in this drawing. Look, but if you see here, it is the realistic problem, and if you see here, it is pure trigonometrical problem. Thank you very much. Hope we will meet in some other class to learn some new topic. Thank you and bye till that.